Mrs. Lisa B. Lombera, your mathematics teacher. Our lesson for today is about factoring. Now, what is factoring? Factoring is just the reverse of special product. It is the process of finding the factors. The first type of factoring is factoring common monomial factor. In this type of factoring, there should be two factors. The first factor is also called the greatest common factor, and the second factor is called the quotient factor. There are two steps in solving for the factors. First, you have to identify the greatest common factor, and this is for the first factor. And this first factor should be written outside the parentheses. And then for the second factor, which is the quotient factor, you just simply divide each term by the greatest common factor. And this factor should be written inside the parentheses. Let us take some examples. For the first example, the polynomial given is 4x squared minus 4y. First, we will solve for the greatest common factor. Now, what is the common factor of the numerical coefficients of the polynomial? Obviously, the greatest common factor is 4. So, GCF, or greatest common factor, is understood to be 4. Now, what about the greatest common factor of the variables? Is there a greatest common factor? Okay, definitely no greatest common factor among the variables. So, if the greatest common factor of the two terms is 4, then 4 will be your first factor. And then for the second factor, we will divide each term by the greatest common factor. Our first factor, or rather our first term, is 4x squared. We will divide this by the greatest common factor, which is 4. What is 4 divided by 4? And it is 1. So, or simply cancel 4 because the quotient is 1. Then x squared divided by 1 is x squared. So, x squared will be the first term of the second factor. For the second term of the second factor, second term is negative 4y. Divide this also by the greatest common factor, which is 4. Negative 4 divided by positive 4 is negative 1. Then y divided by 1 is y. Or cancel negative 4 and positive 4. Quotient is negative 1. Or negative 1y or negative y. You don't need to put negative 1. It should be negative y. 1 should be invisible. So, for the second term in the second factor should be negative y. So, the factor of 4x squared minus 4y is 4 times the quantity x squared minus y. Okay, let's move to the second example. Next, we have the second polynomial. 4a squared minus 16a to the 5th plus 24a cubed. So, the same process we will solve for the greatest common factor of the numerical coefficients. Our numerical coefficients are 4, 16, and 24. How will you solve for the greatest common factor? You can use the so-called the factor tree. In using the factor tree, all factors should be prime numbers. Now, what are prime numbers? Prime numbers are numbers whose factors are 1 and the number itself. Will you give an example of a prime number? Yes, 2 is the lowest prime number. Aside from 2, we also have 3, 5, 7, what else? 11, and 13. Yes, those are prime numbers. So, for the first numerical, which is 4, using the factor 3, for the prime factorization. And for positive 4, we have 2 times 2. How about 16 prime factorization? First, you can use 8 factors are 8 and 2. Since 2 is already prime, you bring down 2. And then for 8, 8 is still composite. So you can still reduce 8 by what factors? By 4 times 2. Then again, we have 2 2's, bring down 2. Then another 2. And then for 4, we have 2 times 2. Okay. So for the prime factorization of 4, we have 2 times 2. And for 16, we have 2 times 2 times 2 times 2. What about 24? Prime factorization of 24. First, you can use 8 and 3. 3 is already prime, so bring down 3. What about 8? You can use 4 and 2. So bring down the 2 prime numbers, 2 and 3. And 4, you can still reduce 4 by 2 and 2. So the prime factorization of 24 is 2 times 2 times 2 times 3. Looking for the greatest common factor, we have multiply all the common factors. Get one of the greatest common factor, or rather one of the common factor, then another common factor, then multiply these 2 common factors, we will get the greatest common factor, and that is 4. So here we have 4 as the greatest common factor among the numerical coefficients. Okay, next, using the factor 3. Now, how about the greatest common factor of the variables? For the variables, you just look for the variable with the least exponents. So first we have a squared, a to the 5th, and a cubed. With the least exponent, that is a squared, will be our greatest common factor for the variables. So aside from 4, a squared should also be the greatest common factor. Let's move to the second factor, or the quotient factor. We will now divide each term by the greatest common factor, which is 4a squared. So again, the complete greatest common factor in this example is 4a squared. Divide the first term, 4a squared, divide by 4a squared. Answer is 1. So we have positive 1. Next, second term, negative 16, a to the 5th, divide by the greatest common factor. Negative 16 divided by 4 is negative 4. Then a to the 5th divided by a squared. How are we going to divide this? Simply subtract the exponent. What is 5 minus 2? Yes, that is 3. And therefore, we have a cubed minus 4a cubed. Okay, next. 24a cubed, the third term. 24a cubed. Divide this also by the greatest common factor. 24 divided by 4 is... What is 24 divided by 4? 6. A cubed divided by a squared, that is 3 minus 2 for the exponent. Therefore, we have a. So, last term is positive 6a. Therefore, the factor of 4a squared minus 16a to the 5th plus 25a cubed is 4a squared times the quantity 1 minus 4a cubed plus 6a. Any question? So we proceed to the next example. Okay, for our third example, again we have three terms. Our numerical coefficients are negative 16, negative 24, and negative 8. So here we have a common sign, and that is negative. So let us first look for the greatest common factor of these three numbers. For 16, using the factor 3, what are the factors of 16? Can we use 8 and 2? Okay, yes, or you can use 4 and 4. Using 8 and 2, or let's say 4 times 4. 4 is a composite number, so you have to reduce 4 to have prime numbers. Factors of 4 that are prime, we have 2 2's, then another 4, whose factors are 2 and 2. So we have 416. The prime factorization is 2 times 2 times 2 times 2. Using factor 3. Then for 24, using 8 and 3. Bring down 3. 3 is already prime. Then reduce 8. Let us use 4 and 2. Again, you bring down 3. This time we have 2. Then reduce 4. Another prime number, 2 and 2. So this is now the second prime factorization, and this is for 24. 2 times 2 times 2 times 3. Okay, next, how about 8? The factors of 8 are 4 and 2, but 4 is composite. Bring down 2, then reduce 4 by 2 and 2. So for 8, prime factorization is 2 times 2 times 2. Common factor, we have 2. Another common factor, we get 1 of this common factor. Then we still have 1 common factor. Multiply these 3 common factors. 2 times 2 is 4, times 2 is 8. Therefore, the greatest common factor is 8. Next, for the variables. First term, we have m cubed, m squared, and to the 7. The variable with the least exponent is m squared. So this is now your greatest common factor among the variables or between the variables. N is not included. Why? Because there is no n in the second term. So our greatest common factor is 8m squared. This will be your first factor in our polynomial. Let us now solve for the second factor. Quotient factor. Divide the first term. Common sign is negative, so it should be negative 8m squared. So divide negative 16m cubed and divide by the greatest common factor, negative 8m squared. Negative 16 divided by negative 8, the same signs, that is positive 2. Then m cubed divided by m squared, subtract their exponent, that is m. And then retain n. N divided by 1, this is understood to be 1, and that is 2mn. Positive 2mn. Okay, next term. Negative 24m squared divided by negative 8m squared. Negative 24 divided by 8 is positive 3. Okay. Then m squared and m squared is 1. So that is positive 3. Okay. For the last term, we have negative 8 m to the 7 n divided by negative 8 m squared. Negative 8 divided by negative 8 is 1. M to the 7 divided by m squared is m to the 5th. How did we get 5? 7 minus 2. And that is 5 for the exponent. Then you retain n. And therefore, we have positive m to the 5th n. So, the factor of the third polynomial is negative 8m squared times the quantity 2mn plus 3 plus m to the 5th n closed quantity. Okay, question. Before we proceed to number 4 and 5 examples. Okay, let's proceed to number 4. Number 4 is very easy. For number 4, consider this as your first term and this is your second term. Common factor between the two terms is a binomial, and that is quantity A plus B. So this is our greatest common factor. For the second factor, we will divide each term. Consider this as the first term. Divide 5 times the quantity A plus B by the greatest common factor A plus B. Cancel A plus B. The remaining quotient will be 5. So this is positive 5. Second term is negative x times the quantity A plus B. Divide this also by the greatest common factor A plus B. Then cancel A plus B. The answer is negative x. So minus x. So this is now your answer. Final answer. Quantity A plus B times the quantity 5 minus x.